Hello guys, welcome to my channel. I am going to discuss about stacks, its introduction, definition and representation using linked list. I am Vishnu Sai Nune. Firstly, what is a stack? Let's see. A stack is a linear data structure. Insertions and deletions are allowed only at the end, called the top of the stack. Let's say, example, stack of books, stack of coins. Any object can be accessed only from the top. Any object can be added only at the top. In a stack, there is only one way to insert or delete. It is required to maintain the pointer to the top of the stack. The element that is inserted last will come out first, that is, the last in, first out principle. There are few operations that we can perform on stacks. There are primary operations such as push and pop, and there are few secondary stack operations like top, size, is empty, is full, etc. Have a look on the push operation. The push operation adds an item to the stack. If the stack is full, then it is said to be an overflow condition. Here it is the pop operation. The pop operation removes an element from the stack. The elements are popped in the reversed order in which they are pushed. If the stack is empty, then it is said to be an underflow condition. Let's have a look on the secondary stack operations. Top operation. The top operation returns the last inserted element without removing it. The size operation. It returns the size of the number of elements in stack. The is empty operation. It returns true if the stack is empty, else returns false. Is full operation. It returns true if the stack is full, else returns false. We will see the representation of stack using linked list. A stack can be implemented using an array and linked list. The benefit of implementing a stack using a linked list in C over arrays is that it allows to grow of the stack as per the requirements and memory can be allocated dynamically. A stack is represented using nodes of a linked list. Each node consists of two parts, data and next. The data part of each node contains the assigned value and the next points to the node containing the next item in the stack. The top refers to the topmost node in the stack. Both the push and pop operations are carried out at the front or top of the linked list and hence take 1 unit of time. Pushing elements in the stack using linked list. First, we need to create a new node using dynamic memory allocation and assign value to the node. Check for the stack is empty or not. If it is empty, then set the next pointer of the node to null. If it is not empty, the newly created node should be linked to the current top element of the stack. Make sure that the top of the stack should always be pointing to the newly created node. We have created a structure to create a node with the data and the next pointer. This structure has the data part and the node pointing to the next. So let's see how we can pop elements from the stack using linked list. Check if stack is empty or not. That is, checking for top if it equals a null. If it is empty, then print stack overflow. If it is not empty, then create a temporary node and set it to top. Now create another variable and copy the data of top element to this variable. Make top point to the next node. Delete the temporary node and return the value stored in temp data. For the pop operation, we created another structure to create a node with the data and the next pointer. The pop method is called. the top of the null if the top of the node equals null, then the user gets an message called empty stack. Else, the temp of data is becomes the top and its data gets deleted. Here is a program to implement stack using linked list. First, we create a structure to create a node with data and a next pointer. First, we called the push method with a dynamic memory allocation malloc statement. We assign a value to the node and make the node as top. The top is always points to the newly created node. Here, the pop method is declared. If the top of the node is null, then a stack underflow statement is printed. The else part gets executed if the top of the node isn't null. It deletes the temp. The display method has the lines of code to print the data. Here, we call the main function to implement the menu driven program. The user is asked to enter his or her choice. There are certain cases to push, pop, display, etc. Let's see how the output of the above program looks. You can see the output has all the methods called like push, pop and display. So this is the representation of stack using linked list. Thank you for watching.